See if you can take especially good notes on the strategies. We've got to talk about these strategies first, and then we're going to implement them in solving some really tough proofs. So first thing I want to do is make a list of the Pythagoreans. So go on this kind of seafoamy green page, move it over, and then let's make this list. Sine squared plus cosine squared, and you should just automatically know this one, equals what? 1. Do you remember the other two that are like it? Okay. Oh, you got one?
1 minus sine.
And you are rewriting this, which is awesome. 1 minus sine squared is the same as cosine squared. Good. And there's one more that's just a rewrite of the black one. I'll make it blue again, and it would be the other way around. Talk to the kid next to you and see if you can figure out that rewrite. That's just the other way around. Yeah, it's just 1 minus sine, or 1 minus cosine squared is sine squared. All right, next thing I want to remind you, and this is very important, pay attention, is that you have two others that are like sine squared plus cosine squared equals 1. And I gave you snappy sayings to remember them. One with the tan. Does anybody remember how to finish that one? Seek. I said, especially if you're a melanoma doctor, the one with the tan is what you seek. Because if you tan yourself too much, like my mom did, she had to have 2 different times where she had to go in and get stuff cut off of her face because she had done a ton of tanning when she was young. And back then, way back when my mom, who's now would be probably 95 if she was still alive, they just didn't know that tanning was going to be bad for you. Most of you guys know that too much tanning or burning can be bad for you. I got a friend who's got red hair, and he's still alive, and he's like 95. And the people that have red hair have a big disadvantage on this. He has had to have multiple surgeries where they've had to remove chunks of his scalp because he got burned on the top of his head over and over again because he was a fishing guide. So he'd be out in the boat, and the sun would be beating down, and he tried to wear a hat and stuff, but the moral of the story is the sun can really be rough on your skin and give you cancer. So the one with the tan is what you seek, especially if you're looking to give them cancer surgery. Let's move on. I know you can safely tan yourself if you spread tan color stuff on your skin. That's about the only way. Otherwise, if you do a tanning bed, there's a chance that could be bad for you. So anyway, I'm just trying to make sure I'm not promoting tanning when I know that too much exposure to the sun can be really damaging. But could you rewrite that 2 different times, please? Like I did with the first one? Like, for instance, I could rewrite this as tangent squared. It's just rearranging it. It'd be secant squared minus 1. Raise your hand if you beat me to that. Okay, good. And then rearrange it the other way. You'd be like, well, what haven't I done yet? How about 1 is equal to? What would 1 be equal to? Jack? Are you with us? Are you doing something else? The old double tap with the home button. Okay, get back with us. Clara, if I rewrite this for just the 1 being solved, can you do that?
Secant squared minus tan.
You are correct. Secant squared minus tangent squared. So that means wherever you see a 1, you can put secant squared minus tangent squared. All right, one more thing. This is called difference of squares. That's a perfect square. That's a perfect square. And that's a minus, which is a difference. That means it's just like this. Do you remember how you can factor that kind? What could you factor it into? X plus 5 and x minus 5. Well, I mean, like, if it was secant squared minus tangent squared, you could factor that. I want you to write that underneath it. Factor it. Jack, what would this one be? Come on, you can do this. We're just doing just like we did a second ago with x squared minus 25, where we said that was x plus 5 and x minus 5. Plus, yep. Yep, that's it. Secant plus and secant minus. And the other one is tangent squared, so you break it up into tangent and tangent. So don't forget you can factor these things. And it's on my list. These are my list of ways you can solve these. And I want to make that list with you. So everybody, you're going to make a really nice, neat list, and then you're going to screenshot it. Okay, so make this a really good list. Yes?
Can you factor the one where it's side squared?
Yes.
Side squared?
So like sine squared theta minus 1, you can factor that. Anytime you have two things that are squared, you can do that. I know it's not the one you asked about, but sine minus 1, sine plus 1. See, I can factor that. And what was the one you just asked
I
about?
said sine squared plus cosine.
Oh, wait, plus? Then that's not a difference of squares. Anytime it's minus, that's difference. Anytime something squared minus something squared, then you could factor it. All right, so if this had a cosine squared there, or, you know, like any combo where there's something squared here, and a minus, you can factor it. All right, so here we're about to make this big, really important list of all the different tools that you can use when you're solving these things. And I want to emphasize there's a right tool for the job. So I know you can't see this in the video at home, but up here I have a painting that is framed, and it's kind of heavy. And the only reason it's staying on the wall so well is because I put a screw into the concrete. Do you get that using a regular drill wouldn't work so well to drill into concrete? But if you have the right tool, it's called a hammer drill, then when you're drilling, it's not only drilling, but it's also pounding. And you have to have a special bit too, because the bit has to be really strong because it's being pounded and spinning at the same time. That's called a hammer drill. And if you have a hammer drill, it's just like drilling into wood. It's no big deal. Just drill right into the concrete. Okay? And if you have the right tool, then it's easy. So that's really true of a lot of contracting kind of stuff. Like if you've got the right tool for the job, easy peasy. All right, so we've got the right tool for the job in math. We just, sometimes you don't know which the tool is. You can't just, it isn't really obvious. So here's a list of tools for solving things like this. Number one, I want you to work on the more complicated side. Number two, or not. Because sometimes you worked on the one side and you just can't get it. So then switch to the other side. Work on that side. Try that way. Because, okay, next, number three. You're writing these down. Don't be too lazy. It'll cost yourself later. Common denominators. Finding common denominators is a really critical strategy. You got to ask yourself, do I want to find common denominators? And number four, or the reverse. What's the reverse of finding common denominators? Well, it's where you had two things that are added together and you break them up. Do you get that I could take something that was a perfectly good fraction that was all put together and break it into two fractions? Give yourself an example of that. That's one of the trickiest things for people. Just when I get you to figure out that you can add things together and get a common denominator, then I got to tell you, sometimes you want to take your common denominator and break it up into two things. You know, this fraction here was all put together and nice, but I needed, for my proof, to break it into two things added together so I can break it. And they can both have a same denominator. It's a common denominator. You can choose not to add them together. All right. Next, number 5. Factor it. Number 6. Jack, would you step in the hallway? I'll talk to you for a second. Bring your iPad with you. Change all to sine and cosine. Change everything to sine and cosine. Number 7. Try reciprocals and let's give you an example of that. Sine versus cosecant. Like if you can replace sine with 1 over cosecant. Eight, try quotients. Anytime you have two things divided, that's a quotient. Sine over cosine is tangent. And the other one that's like that is the flip, which is cotangent. Question?
So are you saying that we should always start with the first step, or
No,
some of
no,
these-
these are 10 different tools.
Okay.
You only need one of them. You might need 2 of them. But I'm trying to list every possible thing that I can think of that I have had to do when I'm solving these things. Okay, that way, if you are in the middle of a problem and you're like, well, have I tried putting in sine over cosine? Have I tried changing everything to sines and cosines? Have I tried to factor it? All right, so the next one is,
Can you zoom out a little bit?
yes, change all to secants and tangents. That's kind of like the whole change everything to sines and cosines. But sine is really 1 over secant, and tangents are really sines and cosines. But the point is, sometimes you want to change everything in the problem to a secant and a tangent. So, and you can. It's hard, but you can change anything to tangents and secants. Like, okay, maybe not anything, but there's a lot of times when you can change everything to secants and tangents. And the last one is one that I have not showed you yet, and it is called conjugates. And I'm going to give you an example. Conjugates like 1 over 1 plus sine theta. That is not a conjugate, but here comes the conjugate. If you have 1 plus sine theta and you multiply it by 1 minus sine theta, do you get that's going to be one of those awesome combos that makes a difference of squares? So you have to multiply by 1 minus sine of theta on the top and the bottom. This is the conjugate of this. And do you get, you're always allowed at any moment in a math problem to multiply by 1. Doesn't that make sense? You can always multiply by 1. Well, why would you want to multiply by 1? You would just, that's 1. 1 over sine theta times 1 over sine theta. Sorry, 1 minus sine theta over 1 minus sine theta. That's 1. So you're allowed to multiply by that. Why would you want to? Because look at this part. That part comes out to 1 minus sine squared of theta. And that should sound familiar. See this one? Rearranged. If I put the sine over here, what is 1 minus sine theta? Cosine. So this can change to this, which then can change to cosine squared theta. Do you get how we just went from a sine to a cosine? That's not normal. It's not easy to take sine and turn it into cosine. But with this technique of multiplying by a conjugate, and again, I'll highlight the conjugates. This was the conjugate to this. Those two are conjugates. When they get multiplied, they turn into this, which simplifies to that. And all of a sudden, something that used to be sine is now cosine. Yay, you have 10, 10's a nice number, things that you can do whenever you're stuck. We have one more week of this unit. You are going to be stuck many times. You're going to refer back to this list and go, okay, am I working on the more complicated side? Oh crap, I've been working on the wrong side. I'll try that. Or maybe if you've tried the more complicated side, switch to the other side. Another strategy is getting common denominators. We will practice that today. Or maybe you want to reverse common denominators and break up a fraction into 2 fractions. If you can factor it, you should. Change everything to sines and cosines. Try the reciprocals, like sine gets swapped out for 1 over cosecant. Try the quotients, like sine over cosine is tangent. Change everything to secant and tangent, and conjugates, like I just showed you. All right, so now we got to practice. I'm taking a screenshot because I think this is such a good list. You should too. Don't often tell you to take a screenshot, do I? I know I told you one the other day, but that was the identities, which are like super valuable. This also, list of like ways to help yourself get unstuck, super valuable. Could you actually use it during the test? No. But you could look right before the test starts to remind yourself of all these strategies. So I'm going to give you, these great hints are all included in the 10 that I gave you, but they only had 6, and I wanted to give you all 10 things that I have thought of. So, all right, I'd like to get to this page right here, and I hope you'll notice that one of the strategies I just gave you is the way you're going to get number 1 fixed. Now, first off, what's the more complicated side, left side or right side? Left side. And then I'm going to work on that side, and I'm going to look, okay, well, what's one of the strategies? I guess I could do that conjugate thing, but I'm going to warn you when to use the conjugate thing. We've already got a squared. That means 1 over cotangent squared, that is something already. I don't need to multiply it by a conjugate. This is something. If you can find it, it's on the sheet. I see a couple people have found it. Take a minute and everybody find that, and then try to get the left side to turn into sine. All right, I'm going to pause for a minute while you and your partner work together. Try to show all the work. The whole point is showing the work. I know sometimes you're halfway through and you can see, oh, this is what I'm going to do. Actually finish it, because I'm going to be grading the work very carefully on these. Because if you can't show every step, of course, I know at the end, duh, the answer is going to be sine equals sine. I know that, and you know that. The question is if you can show the right work in here to get it there. All right, I'm going to pause. You guys try it. I'll be right back. Let's give people a hint. The groups that are on to something, raise your hand if you're confident that you know a good first step. Yes?
1 plus cotangent squared equals CFC squared.
That's cosecant. All right. 1 plus cotangent is right here. See, it's on the board. 1 with the cot is cozy. You need to have those memorized. I'm going to write that over here. The 1 with the cot is cozy. And if it's not on your giant list of things, it should be. I'd add it to it. And I know some of you are like, but the only one on there is sine squared plus cosine squared equals 1. Yes, that's true. I would add this to your list of identities, because what it really came from is everything got divided by sine. If I divided this and this and this, all get divided by sine, then you get 1 with the code is cozy. And then that means replace this with CSC squared. Now I've got CSC over CSC squared, and I'm going to write that in a different way than most of you probably did. Do you get that cosecant squared means cosecant times cosecant? Why would that be handy? Because now you'll see that this one will cancel this one. I have to have a placeholder on the top. What's on the top? 1. Another way to say that is when I canceled that out, I really changed it into 1 over 1. And now it's 1 over cosecant. 1 over cosecant is one of those Pythagoreans. It's one of the 10 steps that I just told you. And that's, sorry, I said Pythagorean, I meant reciprocal. 1 over cosecant is a reciprocal, and so that is just sine. And so then my final answer is sine theta equals sine theta. Would have I accepted this work? I would have liked to see the kid go like this and say I replaced 1 over cotangent with cosecant squared. And I would understand that you broke up the cosecant squared into 2 cosecants. I would get that. I would like seeing this canceled. I really would have said you really ought to have shown a little more work by bringing this down and saying 1 over cosecant. But I think I would have taken it. All right. Let's go over to this one. Now, I know you've never seen anything like secant to the 10th. But right away, should you be thinking like that's kind of like secant squared, but a whole bunch of them? All right, that's the way you should be thinking. How many of them? 5 secant squareds would make secant to the 10th. It's like secant squared, but to the 5th. Okay, so, well, we happen to have some secants over here, but we only got 2. Oh, maybe that's something. The one with the tan. Ooh, you got a saying for that? The one with the tan is what you seek. So secant squared, that won't be that bad. I'm going to replace this right here with secant squared to the 4th times secant squared. And then that's like secant to the 8th. And put it all together, I get secant to the 10th. And you got to bring this down. If you don't bring this down and write this proof statement at the end that prove that you have made them equal exactly, you don't get credit unless you have that at the end. All right. You guys agree that was a pretty easy one? Okay. This page, we found these to be pretty easy. It's the next page that's brutal. This page, I think you can do it without my help. So I'm going to just be quiet for a few minutes. Try to prove these 2. When you're doing stuff, talk to your partner like, I think we should replace cosecant with 1 over sine. Or I think we should replace cosine with secant or whatever. Okay, talk to your partner about what you think you should do. I'm going to pause, solve these 2. Cosecant can be swapped out for 1 over sine. Oh, okay. 1 over sine. And now it's times cosine. And now what could you do?
Equals 1 over tangent.
Wait. We can't just switch this to 1 over tangent. We got to get it to one thing first.
Cosine over sine.
Cosine over sine. Now that is just multiplying, so you can do that. And then you can switch that. That's right on the sheet. What is it? Cotangent. Now, some of you might be like, but I just did 2 steps at once. Is that okay? No, that's the whole point. The whole point is show every step. You can't just skip stuff. On the test, if you had gone from here to here, the answer is no. You can't do that. You have to do every single step. You got to be able to show this obviously follows to this, and this obviously makes that. They have to be obvious. Okay, cool. How about this one? Raise your hand if you've got this one. All right, that's not many people. All right, so Claire, give us an idea of what you did to get started.
Well, I changed the cosine side.
You messed with this side, okay.
Because 1 over cosine is cosecant.
Oh, so you were thinking you could swap out the cosines for 1 over secants.
Yeah.
Now, why would that help?
Um,
I'm not saying you're wrong, I'm just asking. Why were you thinking that was a good idea?
because it would change it to secants, which is the same on the other side.
Oh, the other side has secants. That seems like a good idea then, if we can get a cosine out of there and make it a secant. Would you agree that cosine is 1 over secant? You guys get that one? Okay. Now, help them with just a little tiny more.
Then I just, this is probably wrong, but I switched it from the top to the bottom.
Oh, no, you can't do that. All right. So now from here, you had a genius start though. You looked at what you wanted and you made it happen. We needed secants, you got secants. It's just messy, that's all. So then what are we gonna do? Well, I can't add this to this unless I had a common denominator. That's one of our 10 possible steps. So could you change the 1 into secant over secant? Might be like, how would you know to do that? Well, the 1 is a 1 over 1, and then I just asked myself, could I get common denominator? I need a common denominator to be able to add it. And to get a denominator of secant over here, it's not that hard. I just have to multiply it and make it secant. But then you got to do it on the top by secant. And I got a common denominator. And you do the same thing on the bottom. Secant over secant. Now you've got common denominators. Now, finish it and you'll have a fraction over a fraction. Do you know this is why I did the top 20 with something like this? So that kids would just be like automatic, like, yeah, of course I know that to flip and multiply it. That duh, Mr. Server, that's obvious. Even though most kids get it wrong in the first day of school. Because I want to remind you that fraction over fraction comes up, especially right now when it's obscure fractions that have trig in them. All right, so get a common denominator, add it all together. Get a common denominator at the bottom, add it all together. Then you got fraction over a fraction, and I hope you can handle it. All right, take some time. I'm gonna pause again, work it out. Okay, let's see if you got this right. I'm hoping that you could see that this one had a denominator that was the same, so we can add them. 1 plus secant over secant. And on the bottom, change colors here. I have, well, you make the fraction bar a different color yet. I have 1 minus secant over secant. Get how I got those? Okay, now I'm going to flip this and multiply it up here. So I'm going to go times, and then the bottom becomes the top. Ooh, that's canceling. Anytime something cancels, you know you're on to something. That cancels that, and look at that. I got 1 plus secant, 1 minus secant. That's exactly what I have. I better just clean it up and write 1 plus secant over 1 minus secant. And then I'm bringing this straight down. 1 plus secant over 1 minus secant. Now that is your first legitimately hard proof. How many of you had it done before I showed you how? All right, about 4 of you. That's okay, it's hard. What was the key strategy? Common denominators. Now you could have done this just as easy by taking this side, and what could you change secant into? 1 over, what's secant? 1 over cosine. See how that would have turned into cosine over here? You could have taken this side and changed up both of your secants into 1 over cosines, and it would have worked the same way. All right, now, to do this, I really want to flesh out what the conjugate strategy looks like. So let's say I had 1 over 1 minus sine squared. No, 1 minus sine, just sine. Anytime you see a 1 minus, that's a flag. It's like, ooh, that is probably the kind where I'm going to do conjugates. Did I tell you yet what the conjugate of 1 minus sine would be? Got to get good at this. The conjugate of 1 minus sine would be 1 plus sine. What's the conjugate of 1 plus x? 1 minus x. What's the conjugate of 2 minus 11? Careful. 2 minus 11. Conjugate would be 2 plus 11. So even something that as obscure as that, if I multiply that out, that's going to be 2 squared. The outside and the inside will cancel each other out. And then the last would be minus, because it's a difference of squares, 11 squared. That's called a conjugate. So if you have 1 plus something, you do 1 minus that thing. Okay, so I would like you, if I times by 1 plus sine of theta, then I'd have 1 plus sine of theta here also. Do you get, this is multiplying, really it's just multiplying by 1. Same thing on the top and the bottom. Why would I do that? Because these two right here turn into 1 minus sine squared. 1 squared minus sine squared. And what is 1 minus sine squared? You gotta know these like the back of your hand. I've got it written right here. Sine squared plus cosine squared equals 1. I'm gonna go off to the side and write that just to be like, I know the kids at home can't see this. So sine squared plus cosine squared is equal to 1. So then if I want 1 minus sine squared, that's like moving this to the other side. 1 minus sine squared is cosine squared. So do you get the bottom of this? First it changes to 1 minus sine squared, and then it would change to cosine squared. And magically you had just changed something that was sine into a cosine. Okay, so let's look back at this. What is the conjugate to cosecant minus cotangent? Well, I haven't done enough conjugates then. One plus frog. What's the conjugate? 1 minus frog. Okay, it's just the same exact thing except you use minus. It's the same exact thing except you use minus. Okay, so don't overthink this. What is the conjugate to cosecant minus cotangent? Cosecant plus cotangent. Good. Now, if I multiply that on the bottom, and then I got to do it on the top also. Because that equals 1. If I multiply it on the top and the bottom, then I just multiplied by 1. And look what happens on the top. I get it, the thing I wanted. See? That's what I wanted. And it's on the top now. But what's on the bottom? It's a difference of squares. So it's now they're squared. So it's cosecant squared. And it's a difference of squares. So is it a plus or a minus? Minus. The other one squared. Have you seen that anywhere before? I'm going to say a little saying and see if it comes back to your memory. The one with the coat. Remember this little saying? The one with the coat is cozy. I'm going to write that over here. It's a fact you can use. The one with the coat is cozy. So, couldn't I move this to the other side and have cosecant minus cotangent?
Which becomes 1.
Which is just 1. So the whole bottom is just 1. That is just 1. How were you supposed to know that that was 1? Well, I would take your sheet that we're going to give you. I already told you what the test sheet looks like. I gave it to you on day 1 of the unit. And I've even printed off some copies that you can have in the room here. And I would recommend that you write on there, because these are not on there. One with the coat is cozy, because that comes up a fair amount. And we don't give it to you. It's just a rearrangement of this one, which we do give you. And then it's basically everything divided by sine squared. Then there's the one with the tan is what's the last part? Seek. These two, I'd add that to your identity sheet because they come up a lot. Just came up just right now. Because it was one with the coat is cozy, but rearranged was this. So that's really 1. So now I'm going to bring this down. And that's what we wanted. So now I can bring this down. And do I have to say over 1? No. Dividing by 1 doesn't really do anything, right? So equals this side right here. Cosecant. Cotangent. And it's exactly the same, and that's what we were looking for. Question?
So would we be allowed to put the tools on that sheet as well?
No. The tools have to be coming from your head.
Okay.
So I like that you see that they could be handy, but that's the math part of you learning how to do this, so you got to get those stored in your memory banks. And I know there's 10 of them. It's kind of a pain. But here we go on this one. I hope it's obvious by now. I know this is a hard one, and yet I'm saying it's obvious. What I'm trying to say is, didn't I say to watch for this? And what are you supposed to do if you see a 1 minus something? Conjugates. Everybody use conjugates. You've got a partner. Talk it through. What do you have to multiply by here to make a perfect square? 1 minus cosine and then 1. Hello. What's next? 1 plus cosine. Thank you. I'm glad that wasn't too hard. And then if I multiply by 1 plus cosine on the bottom, I'm going to multiply it by that on the top. See how this one actually works. It's going to take a little while because the bottom turns into 1 minus cosine squared, and then you got to replace that with something, and then it's not like it's automatically all done. It's got a little more work, but just start with conjugates. That's one of your tools. See if you can get it all the way by working the left side. I'll pause for a minute while you try that. So the homework for tonight will be posted in our folder for today, which is March 16th. And so take a look in there to see what proofs I'd like you to try for homework for tonight. That's all I got for the video for today.